This is the 9-2 podcast on power. And we'll like the work, summary of work, where we need to take force and multiply it times a distance. Power is pretty much can be broken down into a mathematical formula too. It's the amount of work done divided by the time it takes that work to done. But there's a little bit more to it than just that. So, like we said, when you carry work, power is work done divided by time interval. But the real key to it is how quickly you do the work, and that is where the time interval comes in. When you carry a load up a staircase, if you walk up the stairs and you run up the stairs, you're going to do the same amount of work. What you're going to be doing, it's going to be with a different amount of power. Power is the rate at which work is done. And if you remember, whenever we said the rate at which something is done, we're always talking about dividing by time. So if you have something that's high power, it's going to not do necessarily it's going to do the same amount of work. It's just going to do it quicker. If an engine has twice the power of another engine, it's going to do the same amount of work in half the time, or twice as fast. Or you could look at it this way: it could do twice the amount of work in the same amount of time as an engine that's half as powerful. And that what that means for an automobile is that you can get an automobile up to a given speed quicker with a more powerful engine. So if you climb a staircase in half the time, you're using twice the power. Now, power, the unit of power, is called the watt, and yes, that's who it's named after right there, Mr. Watt. And it's when you expend 1 joule of work in 1 second. When you do 1 joule of work in 1 second, you don't really expend the work, you do the work. 1 joule of work done 1 second. Once again, a kilowatt is 1,000 watts. A megawatt is going to be 1,000,000 watts. And this is just an example of the amount of power an object can have. You have the space shuttle, which can do 33,000 megawatts of power when it's flying. In the United States, we often use the word horsepower when we rate our engines, rather than joules. And when we talk about electricity, we often talk about kilowatts, and both of them can be used. So to give you an example of how they relate to each other, 1 horsepower is the same as 0.75 kilowatts. So a 134 horsepower engine is going to be a 100 kilowatt engine. That's 134 times 0.75 will give you 100 kilowatts. Another way of thinking about this is that it's the rate at which we use energy. And a light bulb that's, say, 100 kilowatts is more powerful. 100 kilowatt light bulb is more powerful than a 60 kilowatt light bulb, and it's going to use more energy. That's why you often will use a lower rated light bulb. I use a lot of 60 kilowatt light bulbs that give enough light, and they use less power. They have less power. They use less energy. So, if a forklift is replaced with a new forklift that has twice the power, how much greater of a load can it lift in the same amount of time? If it lifts the same load, how much faster can it operate? Well, in both cases, it's going to be twice. Twice the power will lift twice the load in the same amount of time. And I'm sorry, not twice the time. It'll be half the time. You can do the same amount of work in half the time. So how can you calculate power? Power is equal to the amount of work done over a given amount of time.